Sure. Thank you very much. And good afternoon. Thank you very much for another opportunity to share our ideas, if you like, our vision on what can be done in the Russian power sector for the purposes of low carbon development. I hope you can see my presentation. Yep.
Хотел бы начать с того, что, конечно,
I should probably start. Now that we are talking about energy transition and low carbon development, I should probably start with this comparative table, which shows that structural transformation in the power sector is characterized by pretty high inertia. A comparison of 2005 to 2019 shows that contribution of non-carbon resources to electricity generation and consumption has been marginal. In many countries, it has been around 1 or 2 percentage points. It stands at several percent in the United States. It's somewhat higher than that in Europe. And for Russia, it's roughly 1%, which means that substitution of carbon resources with renewables is happening for sure, but it's happening very slowly. And it's a huge industry. We cannot, forklift upgrade it overnight. It costs too much. Now, the power sector very often can actually rely on all sorts of resources, including renewables, nuclear, and hydro. And the two latter are obviously carbon-free as well. And the power sector is, in my opinion, the most flexible industry or the most flexible sector of the economy, which should be at the forefront of this transformation. So it's not really surprising that we are seeing significant progress in the power sector as such in many countries around the world, and in particular in Europe and to a lesser degree in the United States. China is also embracing a significantly higher share of renewables in the power sector. It's happening in some other emerging countries as well, though not in all. Now, if all countries share the objectives of low carbon sustainable development,
два крыла этого низкоуглеродного развития. Одно это энергоэффективность во всех смыслах.
Then I guess most countries will need to work on two fronts. One is energy efficiency, where we're trying to reduce energy intensity per unit of economic growth. And the other one is substitution of fossil fuels with low carbon or zero carbon fuels. Different types of power plants have different potential for a substitution of fossil fuels, per gigawatt of installed capacity. Well, naturally, NPPs tend to generate electricity like 90% of time in a year, while solar power plants will only do it for 15%. So naturally, these numbers for them will differ greatly. And it's a very important consideration. Without it, we will not be able to select the right internal structure, so to speak, for such substitution. Since the power sector is the most flexible or adaptive part of the energy industry, or maybe the economy as a whole, it's only natural that GHG emissions from the power sector in the developed countries have been going down faster than on average for their economies. In developing countries, it's actually different. In many developing countries, supporting fast economic growth is still possible and very much desirable. That's why many developing countries continue increasing their generation output as well as their GHG emissions from the power sector. And they're not really choosy about the type of fuels they're using as they're trying to satisfy the needs of the growing middle class and growing industry. So there are countries where we see extensive growth, and in some of them, peak consumption of fossil fuels is going to happen around 2035 or even 2040. Now, as regards carbon intensity of the Russian power sector, we're not in an ugly situation because of the nature of our fuel mix. Indeed, the majority of our fuels is gas, natural gas, which has a relatively low CO2 emission, and a quarter comes from non-carbon or carbon-free fuels. This actually puts us in a pretty good position compared to many European countries, let alone China. Now, Europe has a very good level, which is in fact a recent achievement, the result of concerted efforts. While Russia's pretty good level is in fact a matter of inheritance, a heritage of Soviet times, and we still can certainly improve it. There are numerous opportunities for improvement. Naturally, we can produce electricity from carbon-free fuels, and we can increase fuel efficiency, and we can do substitution with gas and cogeneration, which has already been mentioned today. And we can certainly substitute coal, which is still used a lot in the eastern part of the country. Many coal-fired plants in the western part of the country were gasified or switched to gas in 1980s. The same needs to be done in Siberia. Now, to go from bullet points to specific figures showing what needs to be done, how much of it, and how much it will cost, we actually use diverse models. And one of our models helps us develop the optimal plan for the evolution of the Russian power sector, which takes into account projected needs, projected demand for electricity from households and industry and so on. It's the classical least cost planning model. And as we factor in the new requirements related to carbon emissions into this model, and they can be introduced as, for example, quotas. Or we can model them through CO2 emission payments related to total emissions or excessive emissions above a particular threshold. So if a decision is made to actually do quotas, and the power sector then will get some sort of constraints or requirements regarding CO2 emission reductions, there can be different pathways. So we have analyzed some scenarios here, which we're showing in the chart, as well as the table. So you see in bold is CO2 emissions in 2050 as percentage of 2018 levels. Obviously, in order to dramatically reduce these emissions, the power sector of the Russian Federation will need to dramatically change its structure. And as regulations get stricter, renewables will grow, and this segment of combined heat and power plants will shrink, and they will also change. I mean, more power plants will become cogeneration plants, as opposed to pure power plants connected to electric boilers.
В принципе, у нас уникальные достаточно условия с точки зрения атомной энергетики.
There will be a choice point for the nuclear power industry. Now, this country is one of the global leaders in the nuclear power industry. We do have lots of technologies and we have great track records in designing and building power plants. We have some pretty good old technologies and new ones are getting developed as well. So the way we see it, nuclear power plants seem like a very competitive, quite a competitive at least, alternative to fossil fuel fired power plants. It's a very attractive technology for low carbon sustainable development. There are different opinions about how much we should stimulate the development of NPPs. You will see that some of the scenarios we're analyzing here assume relatively low contribution of nuclear power. And if we actually maintain, the existing quota, so to speak, for nuclear, we'll need to employ much more expensive renewables. But as you can actually see, in the right-hand part of the bar chart, where a red corresponds to NPPs, we can actually achieve a much cheaper transition to a low carbon economy where NPPs will play a more important role. This way our total discounted expenses will be significantly lower, as the table in the previous slide showed. So renewable power and cogeneration or heat generation can be considered important drivers of the change, but they are expensive. Contrast it with the right-hand bridge chart, which shows how we can get there through primarily in expanding the nuclear power segment. Well, in any case, any of these transitions will require a lot of investments. Our estimates show that every percentage point in a reduction of our emissions will require 2 to 2.5% increase in total capex. And will also demand a significant, roughly 1.5% increase in total expenses. Vadim, I'm sorry, you have 1 minute left. Okay. Evolution of electricity prices. So previous slide just showed investments and total expenses. But the big question is what the price for electricity should be. Well, in order for us to actually live up to this emission reduction commitments, we will need to significantly increase electricity prices in order to recover the funds required for investment. And this is actually one of the key challenges to this transformation, because effectively we will need to balance the needs of low carbon development with finding the right price that the economy and the society will be prepared to pay for a low carbon transformation. Different countries will actually strike this balance in different areas. Like Europe has found its balancing point. The United States has been struggling, but they seem to have found this fine balance. We'll need to do it as well. And it's a political decision, which should, however, be based on very detailed, very thorough, very honest, shall I say, analysis. So I believe it's important for us to continue our collaboration with ACFOR and other institutes, and possibly with the Russian Union of Industrialists and Entrepreneurs, in order for us to arrive at a consensus vision of the kind of a low carbon development that would work best for Russian economy. Yes, thank you very much, Fyodor.